Good evening and welcome to this video for separable differential equations for level 3 integration. Alright, so first things first, what is a separable differential equation? So a differential equation is one that relates one or more functions with their rate of change. So a rate of change is related with two or more of a function. So for example, dy over dx equals to y times of x would be an example of a differential equation because it relates both y and x to the rate of change dy over dx. A separable differential equation is one that can be factored into its product. So for example, f of x can be split up into its product and f of y can be split up into its separate product. Finding a solution to a differential equation means that when the function is substituted back into the differential equation, it makes the equation true. So basically, just like anything else, something that makes it true is the solution to a differential equation. Alright, so second thing is separating variables. So in order to solve a separable differential equation, we need to be able to separate the variables and integrate on both sides with respect to their corresponding variable. For example, if we have dy over dx equals to y times of x minus 3, we can look at y as a function of y and we can look at x minus 3 as a function of x. Because they're both products of each other, it's a separable differential equation because they can be split up into its products. So in this case, we can rewrite this equation so we have only y on one side and only x on the other side. So then we can split up the dy over dx and we can integrate the product function y with respect to y and integrate the product of x, the function x, with respect to x. So in this case, we have 1 over y, and we can move the y to the other side, so we divide on y on both sides. So 1 over y times dy over dx equals to x minus 3. We can then multiply both sides by dx and we'll get 1 over y dy equals to x minus 3 dx. And in this case, we can actually integrate on both sides. So we can integrate 1 over y with respect to y, and we can integrate x minus 3 with respect to x. Our result is that ln of y equals to x squared over 2 minus 3x plus of c. And if we substitute this solution back into the differential equation, you'll find that it makes it true. So dy over dx does equal to y times of x minus 3. Alright, so here's a couple examples. So try separating the following equations, but you don't have to integrate them. So for example, question 1, we have dn over dt equals to some k, which is just a constant, times of n. So have a go at this question, and when you're ready, keep watching the video to find out the answer. Alright, so since it's dn over dt, the rate of change of n with respect to time, we're going to separate the variables of n and k. So we have 1 over n dn and k dt. So our next step for this to find the solution would be to integrate on both sides. So we integrate 1 over n with respect to n, and we integrate k with respect to t. So question 2, so dl over dt equals to nl squared times l minus k. Right, so the answer to this one would be 1 over l squared times l minus k dl equals to n dt. Question 3 is dm over dt equals to k times square root of m. Right, so you should have gone that 1 over square root of m dm equals to k dt. Alright, so a general solution versus a particular solution. So a general solution is one that involves arbitrary constants which arise due to constant integration. So after you separate the variables and you integrate on both sides, you'll find that because we're integrating, there's going to be the constant of integration plus c. So for example, if you were to integrate any function, for example, you were to integrate x, you'll get x squared over 2 plus of c. There's always that arbitrary constant, which is the plus c. So this solution is a general solution because it's not particular to any given situation. So it's just a general solution to a differential equation. It's not a particular solution because it does not represent any particular solution for any particular situation. So a particular solution is one that involves no arbitrary constants because particular values are taken into account to give a particular solution to a differential equation. So in order to get a particular solution, they will usually have to give you a point on the equation where you can substitute to find your c value. So an example of a general solution is y equals to aekt. The reason this is a general solution and not a particular solution is because this involves arbitrary constants. As you can see here, a is an arbitrary constant and k is an arbitrary constant. They are just constants. This is a general solution. A particular solution example is y equals to 4 times e to the power of negative 2t. In this case, we have y with respect, y in terms of t, and in this case, we have no arbitrary constants. Y is directly related to t, and therefore, this is a particular solution. Alright, so finding a general solution. So to find a general solution, the differentiable equation should have its variables separated and integrated while having y in terms of x. So if it's dy over dx, it should be y in terms of x. If it's dp over dt, we should have p in terms of t. Okay, so for example, for this example, I have dp over dt equals to kp. We're going to separate the variables. So we have integral of 1 over p with respect to p equals to the integral of k with respect to t. So in this case, we have ln of p equals to kt plus c, and we should find that p equals to aekt. And this is a general solution because we have in terms of arbitrary constants a and k. Alright, so here are a couple of examples. So find the general solutions to the differential equation. So dy over dx equals the square root of y x squared. Okay, so just ignore this dn over dtf as an error. So just find this general solution to a differential equation. Dy over dx equals the square root of y times x squared. So give this question a try, and when you're ready, keep watching the video to find out the answer. Alright, so first things first, we're going to be splitting up our variables. Okay, so we have 1 over square root of y dy equals the integral of x squared dx. So basically, we're just separating the products of y and x squared. So it's just separating square root of y and x squared. So we have 1 over square root of y dy and x squared dx. So if we integrate on both sides, we should find that 2 times the square root of y equals to x cubed over 3 plus a constant of integration. And if we want to make y the subject of the equation, we're going to divide both sides by 2, and we're going to get x cubed over 6. The reason I didn't change the c is because c is just any constant, and if we divide this constant by 2, it's just going to be some other constant. And because it's just some constant, we don't really have to change it. We can just leave it as a plus c because this is a general solution. So in this case, we have y equals to x cubed over 6 plus c squared. So question number 2, we have dn over dt equals to t times of n minus 3. So give this question a try, and when you're ready, keep watching the video to find out the answer. Alright, so again, okay, we're going to separate our variables. Okay, so we have 1 over n minus 3 dn equals to t dt. And in this case, we're going to integrate the left-hand side with respect to n, and integrate the right-hand side with respect to t. So in this case, we'll have ln of n minus 3 equals to t squared over 2 plus of 3. And we should find that if we take, so ln of n minus 3 equals to t squared over 2 plus of c. So therefore, n equals to ae t squared over 2 plus of 3. So in terms of this, how I got the a is basically, if we have a plus c at the on the right hand side, if we move the ln to the side, we'll get e to the power of t squared over 2, and the plus c can just be moved to our product of a times at the front. So n equals to a times of e to the power of t squared over 2 plus of 3. Alright, so a particular solution. A particular solution exists when you're given a point on the graph. We can substitute this point in and find our constant c, giving us a particular solution. So e.g., find the particular solution to dg over dt equals to g if g equals to 2 when t equals to 0. So as you can see here, we can find the particular solution because we're given that when t equals to 0, g equals to 2. So give this question a try, and when you're ready, keep watching the video to find out the answer. Right, so this question, okay, we're going to, actually there's only one variable, so we're just going to move g and integrate. So g, so we have what, so what we actually get here is integral of 1 over g dg equals to integral of nothing but dt. So in this case, we'll get g equals to a e to the power of t. And if we substitute our original point, so g equals to 2 and t equals to 0, we'll get 2 equals to a times e to the power of 0, and therefore a equals to 2. Therefore, we should get our equation g equals to 2 times e to the power of t. Alright, so word problems in NCA. So in NCA, they won't just give you an equation, they'll always be asking you to form your own differential equation. So the word problems in NCA will always use the word proportional, or not always, but let's say like 99% of the time, they'll give you the word proportional. For example, they might say the rate of change of the population is proportional to the population size at any given time. So this can be interpreted as dP over dt equals to Kp, where K represents any constant. Because when we say proportional, the proportion refers to some constant times of for example, that population. So for example, dP equals to dt equals to Kp. It's proportional because we have a K times the P. So in this case, the K represents some constant as the rate of change is proportional to a population P at any time. Alright, so here's some examples. The rate of change of the height of a tree H is proportional to the square root of the height of the tree. That's question 1. And question 2, the rate of spread of a rumor at a school is proportional to the number of students N who know the rumor and the number that don't know. The total number of students is S. So for both of these questions, I want you to come up with writing up the differential equation to both these questions. Alright, so for the first question, we know that the rate of change of the height of the tree, we know that's variable h, so that's the rate of change refers to dh over dt. So dh over dt is proportional to the square root of height of the tree. So dh over dt will be some constant k multiplied by the square root of the height of the tree, which is square root of h. Therefore, dh over dt equals to k times of root h. In terms of question 2, the rate of spread of a rumor at the school is proportional to the number of students N who know the rumor and the number that don't know. The total number of students is S. So the number of students that do know the rumor is N, and the number of students that don't know the rumor will be the total number of students minus the number of students that know the rumor. So therefore, the number of students that don't know the rumor will be S minus N. So since the rate of spread of the rumor is proportional to both the students that know and the students that don't know, therefore dN over dt equals to k, some constant, multiplied by the number of students that know the rumor and the number that don't, which is S minus N. Alright, so here's an example of an NCA question, and we're going to walk through this one step by step. So the rate of change of a population is proportional to a population size. Given that the initial population size is 5,000, and after 4 days the population is 12,500, find the population after 11 days. So if you want to just give this question a try, and we're going to be walking through step by step in the solution of this question. Alright, so first things first, we're going to be writing our differential equation. The rate of change is proportional to a population size. So therefore, writing the differential equation dp, the rate of change of the population, dp over dt, equals to kp, which is some constant times that population, since it's proportional to the population size at any time. So now we're going to separate variables, and we're going to integrate on both sides. That's step number 2. So we're going to separate, so we're going to say integral of 1 over p with respect to p equals to the integral of k with respect to t. So we should get find the value of the constants at step 3. So for step 2, we should get that ln of p equals to kt plus c, and therefore p equals to ae to the power of kt. So step 3, find the value for constant using initial conditions. So the initial condition was that the population size is 5,000, and initial means t equals to 0. So when t equals to 0, our population size was 5,000. Therefore, population equals to a times of e to the power of 0. But since p equals to 5,000, we know that a equals to 5,000, and therefore p equals to 5,000 times e to the power of kt. And that's a step. So I got this the wrong way around. So this is a step for after step 2. So we have ln of p equals to kt plus c. So p equals to ae to the power of kt, and therefore 5,000 equals to a times of e to the power of 0, and therefore a equals to 5,000. Step 4, we need to find the constant k using the secondary information, which was given that after 4 days, the population size was 12,500. So we're going to substitute those numbers in. So 12,500 equals to 5,000 times e to the power of 4k. Therefore, if we rearrange, we should find that k equals to a quarter times ln of 12,500 over 5,000, which should give us a k value of 0.2291. Our final step is to use these k values. Now we have a particular solution. The reason we have a particular solution is because we have no more arbitrary constants. We know what k is, and we know what a is. So to find the population after 11 days, we can use a particular solution to find the population after 11 days. Therefore, if we substitute t equals to 11, we should get that p equals to 62,131. And that's our final answer. Alright, so another common NCA question is referring to Newton's law of cooling. So the rate of cooling is proportional to the difference in temperature between the surroundings and the temperature of the object. If a coffee was left to cool in a room temperature 18 degrees, how long will it take for the coffee to cool to 25 degrees if it was initially 98 degrees and dropped to 33 degrees after 6 minutes? So give this question a try, and when you're ready, keep watching the video to find out the answer. Alright, so we know that the rate of cooling is proportional to the difference in temperature between the surroundings and the object. So first we're going to define our variables. So let TO be the temperature of the object and TS be the temperature of the surroundings. So the rate of change of the temperature of the object, dTO over dt, that is equal to some constant times the difference in temperature of the surroundings and the object, which is TO minus TS, because that's the difference, and we know that it's proportional, therefore we have that constant K. If we separate our variables, we'll get that integral of 1 over TO minus TS with respect to TO equals to the integral of K with respect to T. So we should get that the ln of TO minus TS equals to KT plus of C, and therefore TO minus TS equals to AE to the power of KT. And if we rearrange to make TO the subject, so the temperature of the object as the subject, we should get AE KT plus of TS. We know that initially, so we're going to use the initial conditions to find our A value. So initially, the temperature of the coffee was 98 degrees. And if we substitute that one in, we should find out we should find our A value is equal to 80. Our A value is equal to 80, and therefore we can use that value in order to find out our K value. So therefore, we can substitute that after 6 minutes, the coffee is 33 degrees. So 33 equals to 80, which is our A value, times e to the power of 6k plus of 80. And if we rearrange, we should find that k equals to 1/6 of ln of 15 over 18, which simplifies to negative 0.279, which makes sense because since the k value is negative, that means that our temperature of the object is decreasing, because it's decreasing over time because it's cooling due to the difference in the temperature. And now we're going to find how long will it take for the temperature to drop down to 25 degrees. So we substitute that the temperature of the object is 25 degrees, and we're going to find for our T. So in this case, we're going to find that T equals to 8.73 minutes, and that's our final answer. Alright, so now we're moving on to a scholarship question. So scholarship concept is rate in, rate out. So for example, this is an example question. So sugar flows into a 100-liter barrel at 0.5 kilograms per liter. 6 liters of the sugar water flows in every second, and 6 liters is drained every second. Assuming the barrel is always evenly mixed, how long will it take to have 10 kilograms of sugar in the barrel if there was initially 1 kilogram in the barrel? So the rate of change of the amount of sugar is always the amount of sugar that's going into the barrel minus the rate of the sugar going out of the barrel. So that's our dx over dt. So we're going to define x as the amount of sugar in our barrel. So dx over dt equals to the rate of increase of sugar into the barrel minus the rate of sugar out of the barrel. So we know that the rate in of the barrel is simply 6 liters times 0.5 kilograms. Since there's 0.5 kilograms of sugar per liter, 6 liters will contain 3 kilograms of 6 liters will contain 3 kilograms of sugar. So therefore, every second, 3 kilograms of sugar flows into a barrel. The amount of sugar that flows out of the barrel is equal to the amount of sugar divided by 100, because that's the amount of sugar per liter since it's evenly mixed. The amount of sugar per liter is amount of sugar in the barrel divided by 100. That's the amount per liter, and 6 of these liters will flow out every second. Therefore, the rate out is simply equal to 6x over 100, which is equal to 3x over 50. So now we can write our differential equation. That's dx over dt equals to rate in minus rate out, which is 3 minus 3x over 50. And we can actually factor out 1 over 50 to make the numbers a bit more nicer for us. So dx over dt equals to 1 over 50 times 150 minus 3x. And we can actually separate our variables. So 1 over 150 minus 3x dx is equal to 1 over 50 dt. So now if we integrate on both sides, we'll get negative 1/3 of ln of 150 minus 3x equals to 1 over 50t plus of c. And in this case, we're going to make x the subject of the equation. So first we're going to multiply by -3 on both sides. So by doing that, we'll get ln of 150 minus 3x equals to -3t over 50. And take note that I didn't change anything to the c, since like I said before, a constant is still just a constant no matter what you do to it. So if I have c and I multiply the c by 1000, it's still a constant. And since it's still a constant, we still don't have to worry about it until we find what the constant is. So should get the final that x equals to -a over 3 e to the power of -3t over 50 plus of 50. So that's our equation for the amount of sugar in the barrel. And now we need to use our initial conditions to find out a value. So we know that there was 1 kilogram of sugar in the barrel when t equals to 0. So therefore 1 equals to -a over 3 e to the power of -3 times of 0, since t equals to 0, over 50 plus of 50. And we should find that a equals to 147. Therefore, our equation for sugar is x equals to -49 e to the power of -3t over 50 plus of 50. And now if we substitute that the amount of sugar in the barrel is 10 kilograms, to find how long it will take for the amount of sugar to reach 10 kilograms, we should find that t equals to -50 over 3 ln of 40 over 49, which simplifies to 3.38 seconds. And that would be an example scholarship question. And it's all about the rate in and rate out. So I hope you enjoyed this video, and I hope you enjoyed this video. If you did, please drop me a like below. If you have any comments, please leave it down in the comment section below, and I hope to see you on the next one. Thank you. Bye.